mic check. Hello everyone, good evening, how are you? You can unmute yourself if you want. Okay, I'm able to people right now. And like, am I audible or not? Hello, am I audible? Okay. So let's wait for 5 more minutes. Generally I wait till 6:10. So let's wait till 6:05, and then if we have enough strength we can start. Otherwise let's wait till 6:10 or something. By that time, I think we have met once last week. Last week we couldn't have this session because I was at a conference. So today we have a session in the regular slot, and tomorrow we have the session for the last week. So please do attend the session tomorrow. That is the same time, 6 to 8 p.m. So like we have 13 people, 14 people, and yeah. Let me quickly introduce myself. So myself, I am Sahil Mishra. I'm a third year PhD student at IIT Delhi. I'm also a PMRF student. So as part of my PMRF TA duty, I have to take these sessions to solve your doubts in this course. For the past session, you can like visit the course page and you will find there that I've also taken sessions in the past, and those sessions are available on YouTube, on my YouTube channel, so you can go through them if you want. But anyways, I don't think like you will be needing to visit those sessions because we will be solving everything here and with a fresh perspective, because over time I'm also learning, and that will ultimately gonna help you. So yeah, okay, people are dropping. Weird. Let's wait till 6:10 then. I was happy with the initial strength, but it's too optimistic. Let's wait for 2-3 more minutes and then we can start. Okay, I was supposed to start. Let's start. People will join whenever they want to join. I cannot wait now. We have a lot of things to finish. So right now the strength is 2. That's fine with me as far as people are like interactive. Okay, the strength is 3 now. So let me share my screen and quickly go through what's happening. Is my screen visible? Hello, is my screen visible? Okay, anyways, so this page, if you go here till week 3, the assignments are live, and week 4 onwards, like week 4 assignment will be live tomorrow. Okay, so once we have week 4 assignment live, from next week we will be discussing this week's assignment, this year's assignments and last year's assignment both together, and that way we will have a proper template of session where we'll be discussing previous year's assignment, then this year's assignment, and then something of our own. And these things actually come in exams, so I would request you all the people to attend it. So yeah, these are this, and the last year's problem solving session you can find here. This is survey. You can go here, and if you click, you will find these videos. These are all by me. So if you click, you will see my face a year ago, how it was. Yep, this is me. So you can go through this and visit the videos anyways. Coming to the part, okay, so 20% course has progressed, and Q&A leads you to here, this page where you can, actually not this page, discussion forum. Announcement is for me, I have to post announcements to you. And yeah, that's all about the course. So I would like to ask if you people have any doubts till now, any doubts in lectures, in assignments, the assignments whose deadlines have passed and all. In lectures, if you have any doubts, just let me know, I'll solve them for you. Because if you don't have anything, then I can start teaching the coding part. Okay, anyways, I don't think so people have any doubt. So this is week 3 live session. Okay. So today we will see the coding and everything, like what is a graph, how you can basically use graph datasets and all, and code around them. Okay, so let's begin. So let me just tell you first of all the graph datasets which we have. So if you go to Stanford Social Network dataset, so this is the folder, Snap repository of Samsung, the Snap project of Samsung, Stanford, not Samsung. This contains the datasets which are commonly used. Commonly used for tasks of social network analysis. So till now you might have seen the undirected graphs, the directed graphs, the sign graphs, temporal graphs, attributed graphs, weighted graphs, bipartite graphs. So these all are available here. And these are with the community graph. So for this to use, you have to wait for at least 3 more weeks, and then you can use these graphs as well. Okay. So anyways, like these graphs are also available as a part of some of the other, I would say, library. Inside the library they are available. So let me just, I won't do anything from my own memory. I will just show you how to use Gemini. How to use Gemini to basically do it. So what can I, this asking what can I help you build? So import a graph data set using network X library. Okay. So it will do it. It will import a graph data set. So see, it has created sample graph. Okay, but I don't want that. I want cancel it. I want data set which is curated and online available. So let's see if it builds something. If it doesn't, then I'll show you how to do it. So this is a famous Karate Club dataset. This is the code given by it. Let me check. I will show you how other datasets can also be used. But till then, let's just stick with it. So Karate Club has 34 nodes something. It has 34 to the 78 edges, something like that. Okay, so this is the basically Karate Club dataset. Karate Club graph. Can we guys make this session a bit interactive? Like, can you guys one by one? Actually, can you guys open this collab on your own computer if you have internet? And if it's possible, I want 1 or 2 people interacting with me. So who wants to volunteer here? it is. You have been from the start. If you have computer, do you want to volunteer? Okay, I think people will drop if I ask them to. Anybody who has a computer, who has a proper internet connection and they want to volunteer with me. That makes the thing easier. Like I would get to know if you are able to do it or not. Hello, am I audible? I want just one volunteer. I don't want that there won't be any humiliation or something. Don't worry about it. Even I'm also doing it like this. Okay. So, anyways, if anybody wants to, they can just like raise their hand like this, and I'll get to know. Otherwise, I'm just continuing. Okay. So this is Karate Club dataset, and this is visualization. So I will go through one by one each line. Okay. So I import NetworkX library as NX. I can import it as anything ABC as well. Don't worry about it. It's just an alias for it. Okay. Doesn't matter. It will be the same graph with different type of visualization. Doesn't matter what type of visualization it is. Okay, so this is how you visualize it. You basically draw the graph. G is the graph with labels. Labels are 24, 25, 27. Node color is sky blue. Node size is 500. Edge color is K. K is something black or something. Line width of edge is 1. If I make it say 12, it will be very thick. Oh, line width is basically node size. Okay, node size. Let me make node size at 10. Then okay, so line width is for the node, not the edge. Then you put a title above it, that is Zachary's Karate Club graph. You print this stuff, and that's all right. That's all. So let me ask, what other graphs does it have? Okay. So there's a dolphin social network. Let's try dolphin social network. Okay, so let's print it and see how it works. So it has 32 dolphins which have 89 connections overall. They have named them something something, and it's like that. Okay, so this is how you can load the online, like the already available graphs, and you can study them like Dorothy Murchison something something, or Bernie Sanderson something something. Okay, so these are the names of, I think, dolphin. I don't know exactly. Okay, so this is okay, this is fine. This is like, these drafts are available to us, they are available to us by library, and that's fine. So what happens if I want to use something different, something that is not here? So let me take a small graph. Wikivote, it has 7,000 nodes and 103, that is 100 and 3,689 edges. If I click it, if I download it, okay, it's not downloaded, and that's fine. Like I don't want to directly use it. Can we like see, can this directly import it? Let me check. without downloading, can I directly directly get it from internet or something? Let me check. And my photo keeps on moving because I have to show my face as per NPTEL policy. So it's mandatory for me. Yeah, that's fine. See, directly I go to this folder, I download it, then I basically extract it using this package, this code. Once it is extracted, I read this file and I get to know, okay, so it has more number of nodes and like edges are the same. The nodes are wrong here. The nodes are 8,000 something. The edges are exactly the same. So I think there's a typo or something, okay. So anyways, let me show you one important statistics. So every time you open this snap repository, let me just post this link here so you guys can also try. Okay. So this you can see, this is, what are these things? This is weakly connected component, this is strongly connected component. Moving to next week, I think next week, week 5 or something, you will get to know about this. Average clustering coefficient you might have already known. Number of triangles is also like how many are forming a triangular cycle. Fraction of closed triangle is the total number of nodes divided by number of triangle. Total number of possible pairs of edges divided by triangle, something like that. Diameter is the largest shortest path, is like to reach two nodes, what is the shortest path possible, and you have to basically take out the largest of that path. Okay, so that is like, these statistics are very important to get to know the size of a network. Sorry about that. So any doubt still now? These are the statistics of the network. Hello, am I audible? Okay, anyways, every time I ask people, am I audible, people drop. So these are like, this is how you load a network or something. This is like completely fine and basic. This is basic techniques to basically sorry. Okay, I want a similar but directed graph. Now I want to show you some network statistics, and that's why I'm using some directed graph to show it to you. Okay. So yeah, that's fine. Wikipedia graph is directed graph only. Okay. So let me show you some of the statistics here. Show the statistics of this directed graph. So as you can see, these are the functions. These are the functions which are available in NetworkX only. So you have this GWiki graph, you find the number of nodes, number of edges, the in degree. Okay, the in degree is basically for all nodes you compute in degree, and then you take out the average of that, and similarly for out degree, and that's how you take out the average in degree and average out degree. So there is a rule of thumb that says that for a directed graph, the sum of in degrees must equal the sum of out degrees, and both must equal the number of edges. Okay, so if you multiply, if I print just this sum, okay, sum of integers, let me print. Okay, so see, sum of integers is equal to sum of out degrees, and both are equal to the number of edges. Thus, the average in degree and average out degree must be equal. The average in degree and average out degree is equal. That is correct. These are the statistics which are available for a directed graph. Okay. So this is how you can use network X to basically compute the basic statistics. Let me ask if it can compute some advanced statistics. So I'm doing this from a perspective of someone who doesn't know anything about this. That way what happens is you people can do it yourself, and compute advanced statistics like clustering coefficient, WCC, SCC, etc. So let's see if it can compute everything like that or not. Okay. So let me run it. Let me see how it computes and what it computes. Because it takes some time to run. I don't know. Don't worry about it. This session we are not going to extend beyond 650 or something. Like I don't have a lot to teach today. Tomorrow onwards I'll be teaching a lot of stuff. Okay, yeah, that's fine. See, top 10 nodes by between the centrality, etc., etc. Okay, so average clustering coefficient is 0. This means that there are no clusters in this network, meaning that this network is all, what should I say, sort of strongly connected network. Number of weakly connected components are this, number of strongly connected components are this. This means that this network is completely like stable and it won't break in such scenario. If the strongly connected component becomes smaller, see, this is equal to the number of edges. Okay, so that's fine, that's fine. These are the statistics which you can get for a network. Okay, so any doubts till now? Okay. So yeah, this is like basic statistics which you can get for a network, and I will share this notebook. Let me just see. You can download this link, okay? This is okay. This is last year's. This is not this year's. This year's I have to get from here. Okay, so I will put this here. So people can go and access it and get to know this basic stuff about coding and all. By the way, this is another guy who teaches, so you can join sessions on Monday and all. I think he teaches. He teaches the same thing which is available with the assignment. I am not going into assignments right now because there are some deadlines of assignments which are not over yet. So from next week we will be doing assignments as well, going through PPTs and everything. Okay, so yeah, this is it about the network stuff. I uploaded it. Now coming to how we can study more about social network analysis. So although this page mentions you can like buy these books and all, and this book is literally online available in the form of a website, so you can open it and say, assume like I go to chapter 1, read online. This is chapter 1, introduction. You can read this online. This whole book is available online. Go to graph theory. Graph theory you will find bipartite and everything. So I'm also attaching the link to this book, and you people can just go through it. It's a nice book which is publicly available for free. Or you can buy the book by course instructor as well. This book is really nice, and this is like the only book which is aligned with the course, I would say completely. Whatever assignments you find here, whatever questions you find here, you will mostly find them in the book. And the content on the videos is also available in this book as well. On Amazon, this book should be 700 or something. I don't know exactly. It's 600 rupees. I think it's like you can buy it if you want. On the release page, it's expensive, but on Amazon, it's cheaper. Okay. So yeah, about the course content. This is all about the course content. Then this is discussion forum where you can, like I already told you, this is the Google Drive. where we'll be putting the content. So, any questions till now? Venkat? Venkat, you can unmute yourself if you want. There are not a lot of people here. Hi, Venkat, hello. Can you unmute yourself? Good evening, good evening. Actually, the thing is, if you see my previous videos, I generally hello. Yeah, I generally prefer taking these sessions in one-to-one interaction type of thing where it's very like feasible for people to interact directly. So I just wanted to know a little background of yours. What do you do exactly? No, no, no. In degree, it was like enjoy or enjoying job, or you're pursuing bachelor's, masters. Okay, from where? Okay, okay, nice. I have actually, I've also been like, I've also studied in Andhra Pradesh only. I have studied in Triple IT Kurnool, so you might know that institute. Yeah, I've done my bachelor's from there, and now I'm doing PhD here. So I just wanted to know if you have any doubts till like week 3 or week 4, something in this course. Mm-hmm. Okay, so let me just open the link which I gave to you. Actually, this link is by Barabasi only. You can see Albert Laszlo Barabasi. Yeah. Let me just show you. Let me just show you the Barabasi. So before Barabasi model, let me just show you this thing. So yeah, so the thing is the social networks, they have to follow 3 properties. Like the social networks generally follow 3 properties. The 3 properties are the small world property, the scale free property, and one is something else. I exactly don't remember. So what is the good thing about these properties is that if you can make a network which follow exactly these properties, you have basically achieved a synthetic network which mimics a real world network. So why do we need to make a synthetic network? Can you tell me? Yeah, but no, actually based on convenience and based for research actually. So the problem is the real world networks are too noisy per se. They don't have the clear data, and they're too big, and sometimes it's not easy to get real world networks. Okay, so the thing is we have to basically we have to basically create a network that is synthetic and that is small in size and convenient for us to basically understand the properties of the exact network. Okay, so I don't know why it's showing 6 to 7 p.m. I think there's something wrong with Google Meet nowadays. It actually allows for 1 hour or something. I need to check this. It should be 6 to 8. Let me check my calendar. Let me make it 6 to 8. See. Okay. Yeah, now it should be 6 to 8. That's fine. Okay, so I think some people joined late. So I was just talking with Venkat about how the social networks behave and how like you can basically use that. So what I will do, Venkat from from tomorrow onwards, I don't have my iPad with me right now. From tomorrow onwards, I will be having my iPad with me, and then I will teach you everything exactly like it is taught about social. Yeah, so please join tomorrow. Today I will just give you a brief, I would say, this brief history, or what should I say, about this book. So this is like the first paper came out in 1994 about this Barabasi Albert thing. So they basically start with this thing, the Bridge of Konigsberg. Okay, so Bridge of Konigsberg had a problem that to reach from some point to some point you have to basically cross each bridge only once. But how is it possible or not? So this is about this. So yeah, I would suggest you go through this video and all. So this is exactly the Bridge of Konigsberg. This is in Russia. So see, a person from C to A, then A to B, and then A to B to D, and D to C, and then it's coming like this. And now it has to repeat an edge. How can this person cover all edges without repeating any edge? Okay, so this is one problem about this bridge. The reason being is Russians used to, like, Russians were bombed by some other countries, so assume like you cross a bridge and it breaks down. So how do you reach the other part of the city? So this is the problem, and this is why network science came up. Not exactly. This is like another case study. So if you go through, you will find these are some of the common networks: number of nodes, number of edges, average degree, etc., etc. You can find everything here. Adjacency matrix and everything is you might have studied. Now going to chapter 3. Chapter 3 is about some random networks. So random network model is like this is known as ADOS Renier model, where basically you predict a network based on some random properties. So you have some nodes, some edges, you predict a random network, and otherwise you have some nodes and some probability, and you predict edges with some probability. Okay. So this is about this, and ultimately we came to know that this random network is not good. Real networks are not poison. They don't have poison distribution, and that's why these random networks are not good, and that's why this Reynolds-Rennie model is not good, and that's because they could not follow the property of scale-free power law, etc., etc. So see, if you open this chapter, you will come to scale-free property, and you will come to know about the power law. Okay. And once you get through it, you will get to know why there was a need to create something such as Barabasi-Albert model. Okay. So Barabasi-Albert model basically follows these all properties, and it's like the most efficient, I would say the perfect model for exact replication of a real world network, and that is why it is like a commonly used method for creating synthetic networks. Then we have evolving networks such as Bianconi Barabasi model, and like this is not in this NPTEL course, but you should study it, and I will teach you this tomorrow when I have my iPad. I don't have my iPad with me right now, but till now the new people who have joined, do they have any doubts about the course, about the content, about the assignments, anything? You can unmute yourself and speak. There's no hard and fast rule about when to speak. You can just like raise your hand and speak like this. Hi, Sumya. Yeah, hello. I didn't get the exact question. Like, generally, yeah, please speak. Assignment solutions will be uploaded after week 5. So once week 5 is done, okay, I will upload solutions till week 5, and then once week 7 is done, I will upload all solutions till week 6, and then once week 9 is done, some other instructor will upload solutions from week 6 till week 9, and etc, etc, okay, but it will be uploaded, okay, because the thing is the deadlines actually pass n minus 2 times, sorry, at n minus 2. So if you have like week 4 live, the deadline is has passed for only week 2, not week 3, okay, so we cannot upload before that, so that's why we have to wait for some time to pass, okay. So yeah, that, I think that was your question, right? Okay, so yeah, and the next thing is, apart from those solution sheets, I will also be discussing assignments here as well, just in case somebody has any doubt. I will discuss the assignment here, and then like you can join this live session, and we can discuss the doubts which you have, the problems you face while solving the assignment, and the techniques to basically solve this types of questions, because questions in exam are also like this only, very easy and easily doable, so it won't be hard. Just keep track of the assignment and go through all the questions which are given to you, okay. Any other doubt? There are like so many people, they can ask if they want. If you guys don't have any doubts, then we can end the session if you want. If you have any doubts, just let me know. I'm like, let's wait for 5 more minutes. Has the deadline passed for week 2? Okay, question 7. What is the diameter of a binary tree with 7 nodes arranged in a balanced fashion? So what is a binary tree? Let me just open something to draw. Still opening this, wait for a minute. Yeah, it's not open. So binary tree is something like this. So sorry, too thick of a pencil. Good evening. Just a second. Let me solve this question first. Then. So binary tree is something which has just 2 branches at each level. So see. This is 7 nodes. 1, 2, 3, 4, 5, 6, 7. Okay, so what is the diameter? Diameter is the longest shortest path. Okay, so the longest shortest path between, assume this node is there, this node is there, the shortest path is 1. So right now the shortest path is 1. Then this node and this node, the shortest path is 2. For this node as well, the shortest path is 2. For this node, shortest path is 2. For this node, shortest path is 1. For this node, shortest path is 2. Okay, so it's like that. Okay, now assume I take this node. From this node to this node, shortest path is 2. From this node, this is 3. Then 3 for this one as well. Then 1, 1. Okay, now I take this node. Okay, the shortest path between this node and this node is 1, 2, 3 and 4. Okay, so this is like the longest possible thing. If I go to this node, the path length will be 4 only. So the longest shortest path is 4 here, which is the diameter. So diameter of this network is 4. Fantastic 4. Got it? Any other question? Other people, do they have any questions from week 1 and week 2? Muni, you have any questions? I think not. And in that case, like we can just finish this session for today here, and let's meet tomorrow. Tomorrow, please do join. We will have quite an interactive session tomorrow, because tomorrow I will have my iPad with me, and then we can discuss everything which we are like discussing here with a like more intricate writing skill of mine compared to this thing. Okay, so just let me know if you have any doubts. Let's wait for 2 more minutes and then we can end. Okay, in that case, if you guys don't have any doubts, like we can end the session, and let's meet tomorrow. Okay, bye bye, take care.